Alright, in this video here we're going to kind of put together all the stuff that we talked about in the other videos that I've done for the unit circle and for reference numbers and terminal points, how to find a terminal point in other quadrants besides just the first quadrant. So the first thing we do is we locate the quadrant determined by our number t. Right, and in the last video that I did about the reference numbers, I talked a little bit about how to do that, and in some of the examples in this video I'll also explain how we do that. So we locate the quadrant determined by that number t. Then we find the reference number, which the reference number, if you watch the last video that I did on reference numbers, the reference number is just going to have the same denominator as the number we're given. So if our t value is 17 pi over 6, our reference number is just pi over 6. Right? If our t value is negative 52 pi over 3, our reference number is just pi over 3. Right? So the reference number is pretty easy to identify. The last video that I did where we talked about the reference number and what it represents, and we did some examples of finding it. That's all well and good to understand that, but when it comes time to just actually find the reference number, you don't have to go through all that work. You can just go ahead and say, oh, I just take the pi over my denominator. That's always going to be my reference number. So for practical purposes, the reference number is pretty simple to figure out. And then for number 3, our terminal point is going to be the same as the terminal point for the reference number. Right? If you watch that video I did on reference numbers, I told you that the reference number is always going to be one of the numbers we know from the first quadrant. And I did another video where I talked about trig hand. So it's going to be one of those numbers that we know from trig hand, either pi over 6, pi over 4, pi over 3, or pi over 2. It's going to be, we can use the trig hand to get our terminal point for that reference number, and then depending on which quadrant we're in, we may need to change the signs of the x and y coordinates to negative values depending on where our quadrant is. Right? If we're in quadrant 3, well then both of the x and the y are negative, so I just make them both negative, and then I've got my terminal point. Right? So those are the basics for finding a terminal point. Locate our quadrant, get the reference number, use the trig hand if we need to get the terminal points for that reference number, and then we just may have to switch the signs, the positives and negatives, to get the terminal point for the t value that we're given. All right, so I'm going to pause the recording here. If you haven't copied those down, if you want to write them down, you might want to do that quickly. Pause it yourself and write those down. I'm going to erase all this, and then we'll spend the rest of this video just doing a whole bunch of examples, as many as we have time for, of finding terminal points for different t values. Alright, so the first couple examples we're going to look at t equals 5 pi over 6, t equals 7 pi over 4, which if you watch the other video I did on reference numbers, these are the two examples I did on that video of just finding the reference number. Now we're going to kind of go the rest of the way and talk about how to actually get the terminal points for these two t values. Right, so for the first one, t equals 5 pi over 6. First thing, in which quadrant am I going to find 5 pi over 6? And like I said on that other video, think about it as 5/6 pi. Right, so we can kind of separate the pi from the fraction, so it's 5/6 of pi. And remember, pi is halfway around the unit circle. Right, it's one of those ones you just need to know that halfway around the unit circle, that's pi. Right, remember, the distance refers to traveling along the circumference. Half of the circle is pi. The full circle is 2 pi. Right, so 5/6 pi. Well, 5/6 is a little bit less than 1 whole, and so 5/6 pi is going to leave us somewhere over here in the second quadrant. Right, that's going to be my t value of 5/6 pi, or 5 pi over 6. Right, so here's where my point is going to end up. All right, so I know that I'm going to be in the second quadrant. And exactly where that point is in the second quadrant is not so important right now. Just knowing which quadrant you're in is what really counts here. All right, so since 5/6, again, that fraction is a little bit less than 1 whole, that's going to leave me in that second quadrant. All right, so now the next thing, once I know which quadrant I'm in, is to find the reference number. Right, and like I talked about on that last video that I did on reference numbers, the reference number is just ignoring whatever numbers in the numerator and just taking the pi over the denominator. Right, so my reference number, my t bar, in this case is going to be pi over 6. Right, technically what the reference number is the distance from that terminal point there to the x-axis, which that distance is going to be pi over 6. Right, so if I go 5 pi over 6, I need to add to that another 1 pi over 6 in order for it to equal 1 pi, which is 6 pi over 6, right? And I explained that on that last video that I did on reference numbers. Right, so my reference number is pi over 6, which means I need to find the terminal point for pi over 6 in the first quadrant. Right, so in the first quadrant over here, and again, I did another video where I talked about the special terminal points in the first quadrant and the trig hand that we can use to find those. So pi over 6 is one of those ones that we need to know from the first quadrant. All right, so if I use my trig hand, if you recall, pi over 6 is the ring finger, right? It's the first one above the pinky, right? For those special ones, remember in the first quadrant it's 0, pi over 6, pi over 4, pi over 3, and then the thumb is pi over 2. So I put down the pi over 6, right, my ring finger. I have 3 above. Remember, above is the x coordinate, so that's going to be a root 3 over 2 for my x coordinate. I have 1 below, so it's going to be 1 over 2 for my y coordinate. Remember, technically it's square root of 1 over 2, but the square root of 1 just equals 1, so we just write that as 1/2. And if you didn't watch the video that I did about the trig hand and those special terminal points, you should definitely watch that one, because we'll be using that for all the examples we do here. I'm going to be pulling out my trig hand and putting down different fingers and doing all that. So if you missed that one, you might want to check it out so you understand what I'm doing when I do all these things with my fingers. All right. So my terminal point for pi over 6 for my reference number, right? So I found that reference number, which is always going to be one of those numbers in the first quadrant, right? And then I get the terminal point for that reference number. Now, the terminal point for my t value, my 5 pi over 6, is going to have the same numbers as my reference number, except the x or the y or both could be negative depending on the quadrant that I'm in. So here, since I'm over here in the second quadrant, right, quadrant number 2, well, if I'm in the second quadrant, think about where that is in terms of the x and y coordinate plane. In the second quadrant, all of my x coordinates are going to be negative, but all my y coordinates are going to be positive, right? Because I'm to the left of the y-axis, so that's all the negative x's, but I'm above the x-axis, so that's positive y's. So I take these numbers here, since I'm in the second quadrant, the x is negative, so negative square root of 3 over 2. The y is positive, so that stays positive 1/2. That's my terminal point for 5 pi over 6. All right, those are the coordinates of that point when I travel 5 pi over 6, or 5/6 pi distance around the circumference of the unit circle. I end up at the point with coordinates negative root 3 over 2, comma 1/2. All right. And the reason that works out, as far as like just taking the values and making them negative, is because the unit circle, a circle is symmetrical, right? So if I just take this point and reflect it over to the other side, to the second quadrant, the point for 5 pi over 6 is a reflection of the point for 5 pi over 6. Since I'm going across the y-axis into negative x values, I keep those same points, I just make the x negative. All right, so again, that's why it's so important to know those special terminal points in the first quadrant and to be able to find them with the trig hand if you don't have them memorized. Because any other point that you want to find on the unit circle in any of those other quadrants is always going to refer back to that first quadrant. Right? That's why we call this the reference number. The reference number is always one of those ones from the first quadrant. It's either pi over 6, pi over 3, pi over 4. I did those backwards. Pi over 6, pi over 4, pi over 3. It's always going to be one of those. And so you need to be able to find those and then just switch the signs depending on which quadrant you're in. All right, so that's our terminal point for 5 pi over 6. For t equals 7 pi over 4, that one took a little while to explain. I'll try to do this one a little bit quicker. All right, for t equals 7 pi over 4, all right, so first thing, which quadrant am I in? All right, so 7 pi over 4, again, think of that as 7/4 pi. All right, well, pi itself, right, that would be 4 pi over 4, or 4/4 pi. That 4 over 4 equals 1. Right, so 7 pi over 4 is definitely bigger than 1 pi. Right, 2 pi over here, that would be 8 pi over 4. Right, 8 over 4 equals 2. Right, so 2 pi would be 8 pi over 4. So where's 7 pi over 4? Well, it's definitely more than 4 pi over 4, and it's not quite 8 pi over 4, but it's as close as I can get to 8 pi over 4 without hitting it, which means it's going to stop before I get to 8 pi over 4. Right, it's going to go past the third quadrant and into the fourth quadrant. Right, and again, because 7 is 1 less than 8, I know it stops right there, just before I get to 8 pi over 4 or 2 pi. Right, so for 7 pi over 4, I'm going to be in the fourth quadrant on my coordinate plane. All right, and again, if you want to compare that to over here, this is 3 pi over 2, which if I multiply the top and the bottom of that by 2, I would get 6 pi over 4. And we can see 7 pi over 4 is a little bit bigger than 6 pi over 4, but not as big as 8 pi over 4, which means it's right there in the middle between them in that fourth quadrant. All right, so when you're using your guideposts, and again, you use the x and y axis, or at least I do. I use the x and y axis points as guides to how far around the circle I go for all these t values. change each number into the denominator that you're looking for. We're looking for a denominator of 4. So 7 pi over 4 takes us over there because it's bigger than 4 pi, bigger than 6 pi over 4, but not as big as 8 pi over 4. All right, so my reference number then, the distance from here to the x-axis, is going to be just pi over 4. Once again, just ignore the number in the numerator and just take the pi over your denominator. All right, so my reference number t bar is pi over 4, which means I go to my first quadrant, to my point for pi over 4, which is the one that's right in the middle of that first quadrant, and I get the terminal point for pi over 4. So once again, my trig hand, pi over 4 is the one in the middle, that's my middle finger. So my x-coordinate, the number of fingers above, is root 2 over 2. And my y-coordinate, the number of fingers below, is root 2 over 2. All right, so that's my terminal point for pi over 4. And now I need to figure out, well, what's it going to be for 7 pi over 4? Well, to get from pi over 4 to 7 pi over 4, I'm just reflecting it over the x-axis down into the fourth quadrant. Right? In the fourth quadrant, I've got positive x values, but negative y values. Right? So it's going to be positive root 2 over 2. The x stays positive, but the y becomes negative root 2 over 2. That's my terminal point for t equals 7 pi over 4. All right? So again, we identify the quadrant. We take our reference number, which is going to be one of those numbers in the the first quadrant, just keeping that same denominator. And then it's just whatever that terminal point is from the first quadrant, change the x to negative, change the y to negative. If I was in the third quadrant, I would change both the x and y to negative, right? And that's just based on your prior knowledge of if I have any point in the fourth quadrant, it's going to have a positive x coordinate, but a negative y coordinate, right? Because it's over to the right for positive x's, but it's down for negative y's. So I just take those numbers, make the y negative. That's my terminal point for 7 pi over 4. All right, I'm going to pause this again and erase these examples and put up one or two more that we'll also work through. All right, I put a couple examples up here, a couple more that I actually put all the work and everything up here, and I'm just going to talk through them real quick because we're starting to run out of time on this video. So the next one is t equals negative 2 pi over 3. Remember, when it's a negative t value, you still start on the positive x-axis, but you go clockwise. You start moving downward, right? So for negative 2 pi over 3, I'm moving in this direction here. Now, 2 pi over 3, 2/3 pi, that's a little bit less than 1 full pi, right? 2/3 is a little bit less than 1. So that's going to take me over here into the third quadrant, right? If I had negative pi, I would go all the way halfway around the circle. Negative 2/3 pi is going to take me a little bit less than that. So I'm in quadrant 3. Now, my reference number is pi over 3, right? Again, forget that 2 in the numerator, and it's just going to be pi over 3. Also forget the negative, right? So our reference number is always a positive number. In this case, it's pi over 3. So I go to my first quadrant, pi over 3, my trig hand, pi over 3 is the index finger, right? So my x-coordinate up above is 1 over 2, and my y-coordinate below is root 3 over 2. So my terminal point for pi over 3 is 1/2, comma, root 3 over 2. I then reflect that over into the third quadrant, and in the third quadrant, both of my x and my y coordinates have to be negative, so I just take those numbers and make them both negative. Negative 1/2, negative root 3 over 2, that's my terminal point for negative 2 pi over 3. All right, so that's our example there. And then the last one we have t equals 29 pi over 6. Now 29 pi over 6, 29 is a pretty big number compared to 6. So what I broke this down to, 2 pi, remember 2 pi is 1 full lap around the circle. 2 pi is the same as 12 pi over 6, right? 12 over 6 equals 2. Right, so 29 pi over 6, that's 12 pi over 6 plus another 12 pi over 6 plus 5 pi over 6, right? 12 and 12 is 24. 24 plus 5 gives me that 29. All right, so both of these 12 pi over 6 represents full laps around the circle. So to do this one, to get to that terminal point of 29 pi over 6, I actually go all the way around the circle once, right? That's one of those. All the way around the circle again, that's the second one. And then I go to where 5 pi over 6 is. Right, so 29 pi over 6 and 5 pi over 6, we call those coterminal points, right? They end up on the same terminal point, so they're coterminal, right? They share that terminal point. It's just the 29 pi over 6, I did 2 laps around the circle before I ended up there, right? So 5 pi over 6, right? 5/6 pi, a little bit less than pi, so we're in quadrant 2. My reference number is pi over 6, which that's my ring finger. Root 3 over 2 is my x, 1 over 2 is my y, and then I reflect that into the second quadrant, so I'll make the x negative. I get negative root 3 over 2, comma, 1/2. All right, so those are some examples of using the trig hand, using the unit circle to find some terminal points for some different t values.